Welcome to clickmyproject.com. Now let me discuss about optimal data compression techniques for smart grid and power quality trend data. Here we compress the document image by the use of LZMA algorithm. It stands for Lempel-Ziv Markov chain algorithm. It is used for lossless compression. In pre-processing, we remove the noise from the image. Then we apply the wavelet transform to the image. It will decompose the image. Here we quantize the image by the use of wavelet. It is more robust under transmission. Then we apply the LZMA algorithm. The total image pixels are considered as stream bits. Then the bits are separated as a number of packets. Then the packet bits are encoded. For encoding process, it will use the adaptive binary range coder. Finally, we get the encoded value from the algorithm. After compression, we apply the decompression algorithm. It is the reverse process of compression. The output of the decompression will give to the inverse wavelet transform. Finally, it will produce the reconstructed image. We propose the LZMA algorithm as a best performing one. Here, we achieved the compression ratios were improved with the predictive modeling in place. Typically, we observe CR improvements between 5% to 15% in comparing with the plain best performing lossless compression algorithm. Significance of this extra saving is crucial in the emerging data intensive smart grid technology, where huge amount of data will be hosted in enterprise data warehouse, but only relatively small portion of the data will be actively analyzed. This is the flow of our project. Here we have to provide our input image. The input image would be the document image. The document image is passed to the pre-processing stage. In pre-processing, here we are filtering the Gaussian noise. For filtering the noise, here we are using the infilter function. The noise-free image is passed to the further process. Here we are applying the wavelet transform. The image is decomposed by the use of wavelet transform. Wavelet transform has become an important method for image compression. Wavelet transform partition a single signal into a set of functions called wavelets. Wavelets are obtained from a single prototype wavelet called mother wavelet by dilation and shifting. The wavelet transform is computed separately for different segments of the time domain signal at different frequency. The decomposed image is passed to the LZMA encoding. LZMA is the compression algorithm. It is used for the generating the bit stream. In LZMA, the compressed bit stream is generated. Here, for encoding, adaptive binary range coder is used. The stream is divided into a packet, each packet describing either a single byte or a sequence with its length and distance, implicitly and explicitly encoded. Each part of each packet is modeled with an independent context, so the probability prediction for each bit are correlated with the values of that bit. The output of the LZMA encoding is the bitstream values. The bitstream values passed to the LZMA decoding. The LZMA is that lowest level decoded 1 bit at a time by the range decoder at the direction of the LZMA decoder. The output of the LZMA decoding is passed to the inverse wavelet transform. The inverse wavelet transform uses the predict and update the operation of order 1 using different predict and update operation of higher order. Many other wavelet transform can be built using the lifting scheme. It is the reverse process of wavelet transform. It will merge the all splitting values, so it will convert to the original forms. Finally, we get the reconstructed image. Now let's see the execution part. Here I am having cmain.m file. This is the main file. Select this file, right click, run the file. This is our guide design. Here we have to provide our input image. In dataset, totally I am having 6 document images as a dataset. Now I am providing one image as an input. The provided input image is passed in the displayed in the first axis. In pre-processing, here we are removing the noise. For removing the noise, infilter function is used. The noise free image is displayed in the second axis. This is the filtered image. The filtered image is passed to the Wavelet Transform. In Wavelet Transform, here we are decomposing the images by the use of lifting scheme. Now let's see the result of Wavelet Transform. This is the result of the Wavelet Transform. The output of the Wavelet Transform is passed to the LZMA algorithm. LZMA, in LZMA compression, it takes the whole bit stream as a n packets. These n packets will be compressed and the bit stream will be the output of this LZMA compression. Now let's see the result of LZMA. This is the bit stream values of the provided input image. This values is displayed in the first table. The bit stream is passed to the decompression and it will provide the quantized image. Now let's see the result. This is the LZMA decompression result. After decompression, here we have to apply the inverse Wavelet Transform. The inverse Wavelet Transform uses predict and update operation of order 1. Many other Wavelet Transform can be built using the lifting scheme. It is the reverse process of Wavelet Transform. It will merge the all splitting values, so it will convert to the original form. Now let's say the inverse Wavelet Transform. It will produce the original document image. This is our reconstructed image. In calculation, here we are computing the compression ratio and bits per pixels to the document image with the compressed image. Here we are showing the algorithm of LZMA and it will provide the lossless compression to the document image and it will provide the better result. Thank you.